Alright, so Magic X for factoring. The Magic X for factoring is also known as the box method. So after we do factor by grouping, we're going to do factoring where A values are greater than 1. And when the A values are greater than 1, the Magic X is a shortcut to help you factor always without needing guess and check. It also works if A values are not greater than 1. So what this says is that we're going to fill in two values on the left, or we're going to fill in a value on the top and the bottom. And then we're going to use the idea that the two values on the left need to multiply to the top and add to the bottom. So multiplying to the top is easy. -3 times 9 gives me -27. And then adding for the bottom, -3 plus 9 is +6. So the reverse of that is if you're given the top number and given the bottom number. So now you need to fill in the two sides such that 12 is the multiple and 7 is the sum. So you need two numbers that multiply to 12 and also add to 7. So two numbers that multiply to 12 and add to 7 are 3 and 4. So two numbers that multiply to -18 and add to -7. So if the top number is a negative, that means that one of my side numbers is negative. And one of my side numbers is positive, because a negative times a positive is a negative. So that in this case means the larger factor of 18 needs to be negative since the bottom is negative. So that's a -9 and a +2. So the factors of -18 that sum to -7 are -9 and +2. What's nice about being given a side and the top, so you need a number that multiplies by 2 to get to -30. So since that top number is negative and 2 is positive, that would be a -15. And then once you have these two that work for this, you just add them together to get the bottom. So that's -13. All of the cases for factoring are going to be where you have a top and a bottom, because from the quadratic form, in standard form, this is going to be A times C, and this is my B. So that's how it relates to a quadratic. The top is A times C and the bottom is B. So two numbers that multiply to -10 and add to 3 need to be one negative and one positive again. However, this time, since the bottom is positive, my larger factor is positive. So that's -2 and +5 gives -10 and +3. Two numbers that multiply to 24 and sum to -10. If your top is positive and your bottom is negative, both sides need to be negative, because a negative times a negative is a positive, and two negatives sum to a negative. So that's -6 and -4. So that is how we utilize the Magic X. And then we're also going to talk about the GCF. So the GCF is a method for factoring in which we pull out the greatest common factor. So the greatest common factor is the largest number that multiplies to everything else in that problem. It is a technique that helps us with factoring. So factoring is a rewriting of an expression as a product of its factors. All of lesson 3 for chapter 5 is focused on factoring. The GCF is a technique we're going to utilize in factoring. We are going to take a common factor of all of the terms in the expression and factor it out. This can be a number, a variable raised to a power, or a combination of numbers and variables. Does anybody still need that? Okay. So in that example, we have 6x plus 18. So you have to look at the 6 and the 18. Since there is only an x on the first term, we can't take out a variable. But those 6 and 18 have a GCF of 6. Because 6 and 18 both divide by 6. So factoring out that GCF leaves me with x plus 3. So this is what we call factored form. We have taken out the GCF and left behind the product of its sums. We have 9x minus 18, so the GCF is 9. If I factor out A9, that leaves x minus 9. And again, if I distributed it, then I would get 9x minus 81. So you can also self-check your GCF by just distributing it back in. Okay, and then in the next one, we have x, why won't you let me write? I'll just do it over here. You have x to the 4th plus x squared. So now I have no coefficients, just variables. So they have at least 2 x's in common. So they're going to take x squared out of both. When you take x squared or a variable away, you're subtracting the exponents. So that leaves x squared plus 1. So when you distribute it back in, you add, not multiply. And then in the last one, we have 5x cubed. I have no idea. Plus 15x. So both have a GCF of 5 and both have a variable of x. So you take a 5 out of each and an x away from each, and that leaves x squared plus 3. So if I were to distribute that back in, I get 5x cubed plus 15x. So for your homework, you're doing that next page. So you're doing 1 to 28 with the magic X's. And then on the back, you're factoring out the GCF. T1.